So the focus of this morning's presentation, we're going to shift to I-94 in Valley City. And we have two speakers today, Mike Johnson from North Dakota DOT and Brandon Barnes from Barr Engineering. And they're going to tell you about the design and construction of an interesting drainage improvements project where they dealt with some site constraints and also recap on a few surprises that they encountered along the way too. So please help me welcome our speakers this morning, Mike and Brandon. All right. You better be. Figured you would, Jeremy. All right, I think I got this up and running. All right, morning everybody. Hey, good. I didn't hear much of that with Ron, so I appreciate that. Yeah, thanks. So welcome. For those of you in the door, there are a couple seats up here. If you want to come for church, you can come up front. But we are going to be talking today about Valley City Drainage Project. This has been a very, very interesting project that myself and Brandon have worked on for the past number of years. And I always joked with Brandon when we were doing this project that, you know, there's so many unique and odd things with this project that we could take this thing on tour and tell a good story. So this is stop 2 on our tour. Stop 3 hasn't been assigned yet, so if anybody's got any cities they want us to hit, please let us know and we'll get there. But appreciate you being here this morning, and we'll talk through this. Now, I will say, just so everybody's aware, some of the details on the slide. I don't have access to the laser pointer, so some of the details I'm going to be kind of talking through and pointing through, so try and use your imagination a little bit. But all right. Okay. A little bit of our agenda that we're going to talk about today. We'll give a little project background, some purpose and need of why we did the project, why the need was there. We'll go through some of the design elements, challenges that we experienced, and then talk about some construction elements and some closing remarks that we have related to the project. So talking about that purpose and need. So Valley City, most of you in this room probably are aware of, is one of our smaller urban cities that we have in North Dakota. It lies within a valley along the Cheyenne River. And interestingly, when I was kind of preparing for this presentation, I was just kind of looking like, how deep is it there when you get to the bottom of the river? And the interstate on either side of Valley City is 200 feet higher than that river channel. So I thought that was interesting. So it literally is Valley City sitting down in that hole. Interstate 94 runs east-west through the city. And, you know, we had this challenge of identifying a drainage project and trying to figure out how we could improve some of the drainage along exit 290 at Interstate 94. One thing that's really interesting, we had to figure out how much water is really coming here. What are we really dealing with? So one of the elements to look at was what's our catchment area? And you can see in that figure to the right, there's a little teeny tiny yellow polygon. That's our project area. So you can see the amount of drainage. It's just under 40 square miles of drainage area coming to this one isolated little quadrant of an interchange that dumps into a pipe and eventually makes its way to the river. So we really wanted to kind of grasp and get a hold of how big our area was and what we were dealing with. As we got going early on in the project, there was an active slide repair project the DOT was working on I-94, just east of exit 290 on the north inslope, just off the shoulder. So this slide had been active for a while, had been causing some issues. We had to do some emergency closures and some repairs to the shoulder to keep the interstate operating and function. So this slide repair project started, and it was kind of on a fast track to get something out there, get something repaired so we could maintain the interstate functionality. While that project was under development and going through its normal process, this drainage project all of a sudden kind of emerged. And this was a project that the former district engineer in Valley City, one of those things he always had on his list to say, I want to take care of this before I retire. Well, he retired about 8 months after we started, and he was long gone by the time we got done. But it was one of those things he wanted to take on and make sure that was addressed as it relates through this area of Valley City and along the interstate. So right away, those two projects are like, this makes good sense. Let's combine these two things. They're in the same kind of area. They overlap each other. Maybe we could even utilize some benefits of maybe the drainage improvement that we could do along this ditch in the interstate could act as some sort of buttress system for our slide repair. And multiple iterations were taken, and the process was gone through several times, and it was really found out that trying to get a profile to work with a box culvert, so that would also help the drain or the slide repair system, the stars weren't aligning, but the need for the slide repair was there. So it was ultimately determined to separate the two projects again. The slide repair project moved forward. You can see the soil anchor walls here on the end slope, and then we made a separate effort to tackle the drainage project. Give you a little point of reference of where we're at in Valley City here. So the interstate is kind of cutting right through the middle of that picture there, east-west. That interchange is exit 290. On the far west end is the north off-ramp. And just to the west of that is where all that 39.5 or roughly 40 square miles of drainage dumps into that quadrant, works its way under the ramp into a pipe system that follows along the frontage road, just on the south side of Main Street. And then those green lines that you can kind of see there, that first turn goes 90 degrees in between those buildings. That's the pipe system today. So it goes under the frontage road, takes a 90-degree turn, heads south to the ditch, and daylights to the ditch, and then it's ditch drainage all the way to the river. That's the pipe we're really trying to address here. It was aging infrastructure, reaching the end of its design life. They're also under County Road 19, which is the crossroad at the interchange. There's a 13-foot diameter pipe that went under there that had the same age and condition that we also wanted to try and address with this project. So really we're trying to determine what is the best way to address these pipes that have aging condition and have outlived their service life. So a little history first, kind of give you some context. So initially, this was an open ditch section along just to the south of Main Street, north of the interstate, with a couple approaches. Other than that, it was an open ditch system. Sometime in the late 50s, the DOT put a 9-foot culvert pipe through that area, through kind of when we, on the north side of the right-of-way, to bury that drainage ditch. However, the rest of the drainage ditch to the east and then to the south through those private properties remained an open channel ditch. Well, shortly after the DOT put our pipe in, the developer, the landowner decided, you know what, I really want to develop this land, I want to bury this ditch. So he on his own went and put in some pipes and buried it. However, he didn't consult with the DOT, he didn't do a proper design, and eventually the design that was put in, our 9-foot pipe dumped into an 8-foot pipe, which dumped into a 7-foot pipe, and then into a ditch. Most of you here know that that's backwards. The landowner was notified of that, and the letter that was sent basically told the landowner, you assume full ownership and full responsibility for maintenance of this pipe in the future. Well, that pipe, or that letter was just sent. Nothing was returned back signing, I acknowledge this, I agree with this. So it just kind of went into oblivion. So when it became time to address this need, it really became an issue that DOT needed to take the lead on it and make sure that this got done the right way. Here you can just see another little bit of area of the picture. You can see how much water is kind of working through that pipe. Sometimes it freezes up. It's not stagnant water. It's typically moving it at most times. All right. Drainage modifications. So the yellow lines are really what we're trying to address here. There's a pipe underneath that exit ramp. The yellow line is the main 9-foot, 8-foot, 7-foot pipe that goes under the frontage road, takes a 90, goes between those two businesses, dumps into the ditch, and then the smaller yellow one at County Road 19 is the 13-foot diameter pipe that we were also trying to address. Those are the main things we were trying to address with this project. Now, there's some green lines along the main street. Those are also storm sewer that fed into the existing system a little bit. So we had to address those too and determine, can we tie them into any new system? Do they have to operate on their own? How can we make that work? And then you can kind of just see the other pipes that are in the area along the interstate, along the frontage road. Our study area is a little bit bigger. We found out through going through the design process that we had some actually floodplain issues. One of the businesses where that pipe daylights sits pretty low, and I'll have a picture here later to show you that. We had some flooding back up there, and then also downstream near those homes, a 100-year event backed up into some of their yards. So we were also addressing those items, the project. Site constraints. So one of them I already talked about was slide repairs. Well, that was only one of the slides that we know of in this area that are active or we're tracking. The slide that was repaired is between the interstate and those businesses on the north side of the interstate, on the east side or right-hand side of the picture. North of that, north of Main Street into the grass area, that was an active slide that the DOT did a separate project on to fix and correct. One to the west is a slide. That whole area on the north side is old railroad embankment. In the southwest corner of the interchange, that was a slide that the department repaired. Shortly after it was repaired, it failed a little bit. If you drive through there, you can kind of see some of that. And then in the southeast quadrant is just another one that we're monitoring. So this whole area of this interchange is just constantly just kind of sitting there swinging and moving. Utilities, like any project we all work on, there's all kinds of utilities. Here we had your normal fiber optic, cable TV, sanitary sewer, electrical, and then of course some asbestos water main we had to deal with as well. Here's the picture that's really interesting, the concrete block basement. So this is the north-south piece of that pipe where it daylights into the ditch. You can see how close it is to that building. Actually, that building is a 2-story building. It goes underneath the retaining wall that retains the parking lot above to the driveway entrance down below to some access doors, garage doors. So it's very, very close to the building. This was definitely part of the consideration on alternatives and where we could send this alignment, how close this pipe was, how close could we work to these buildings so that we wouldn't jeopardize their structural integrity. It was a very large consideration on how we were going to deal with improvements moving forward. Constant discharge, I mentioned that already. There's a good amount of flow coming through this pipe, constantly going. How do we address that during construction as part of the design? Shallow groundwater, we're obviously going to be trying to dig a hole here to either put in a new pipe, new box culvert. Shallow groundwater was definitely present. We knew we were going to run into water. We needed to try and address that in the design. Limited right-of-way. So it's kind of hard to see on that picture on the left, but that main larger building is a porta storage business, and then on the front of that building, 6 feet from a right-of-way, they have some of those little pods that have a lock on it. So people were driving up to the front of the road, accessing their facility, and then heading out. So we had really limited right-of-way there. It doesn't seem like it when we have got Main Street and the frontage road, but the existing pipe, the existing 9-foot east-west pipe is actually straddling the right-of-way line. So it was half on our right-of-way, half on the private property. That was also an issue we had to deal with, how are we gonna, plug it, deal with it during construction, where can we place a new alignment, knowing that it was straddling the existing right-of-way. So a little bit on alternatives. Going through our iteration of processes, we really kind of narrowed it down to about 4 alternatives. I'm going to kind of step through each one of them. They are color-coded. I'm going to walk through here and talk to you about each alternative and give you some details on pros and cons, and then what we ultimately decided to move forward with. Alternative 1. This alternative was definitely our shortest box culvert alignment. This one started in that northwest quadrant interchange where I told you all that 40 square miles dumps into. That's really our kind of our pickup point. This alternative was to install a box culvert in that quadrant, go under the interchange ramp, and then follow along the interstate near the interstate right-of-way line, go through County Road 19, and then daylight into the existing ditch. A number of items are relative to this. So the red line here on the plan view is the alignment of the box culvert. There was also a minor pink line coming from that building next to the existing pipe that we had to address some pipe to make sure that we could address the flooding. You can kind of see the constraints a little bit on this profile view that we're dealing with. Obviously, the dashed red is our existing ground profile. The green line is the proposed top of box, and then the blue line is the invert elevation of the box. And that's going to be the similar for all these alternatives. So each one of these alternatives, we'll do a little bit of a snapshot view for you. So the plan view has a black circle on it. That's where we can kind of picture that our Google Street View, if you will, is showing down the ditch. The issues we had here were relative to the existing interstate embankment. There isn't really much of a ditch section there today. That interstate embankment goes straight down to the fence line. We had a lot of concerns with obviously all the movement in this area that's already present. Do we really want to dig up a hole, put a new structure underneath this area of the interstate? Will we see any additional movement? So this alternative, not only did it install a box culvert, but you can see in that cross-sectional view, we also had secant pile walls on both sides of it to permanently help retain that slope area along with the box culvert. Because of that, even though this box culvert option was one of our shortest ones, it was actually one of, or not, if not the most expensive one. 40% of the cost of the project was the secant pile wall, so the box culvert was only about 9%. So obviously it's, you know, you're looking at those economies of scale. It's like, wow, geez, it's a really short alignment. This should be really good. But when you have those other elements that come into play, it really can affect the design and the eventual outcome of alternatives. Alternative 2 is this light blue cyan color. This alternative roughly followed some overlapping of the existing alignment. The only difference here is our start point in the northwest quadrant went under the interchange ramp, and instead of going underneath the frontage road, we put it in the grassed area between Main Street and the frontage road. Kind of give us a little bit of distance from the right-of-way and that existing pipe. So it traveled along that grassed area. However, it did take a 90-degree turn just west of the existing pipe. So kind of balancing that point between those two existing buildings to see if we could optimize an alignment through that area. It would take another almost 90-degree turn in the ditch, continue as a box culvert under County Road 19, and then it would daylight into that existing ditch to the east. Here we go, we have our Google Street View standing between those two buildings. You can kind of see that alignment and the infrastructure that's already there. Because of that, and because of the other concerns with the buildings and the existing pipe, this alternative also incorporated those secant pile walls to make sure we were just in a limited footprint. Yeah?
What size is the new culvert?
It's a 10 by 7. 10 by 7 culvert.
Thank you.
Yep. Question. You can't see it on that cross section? You're good. Good question. Thank you. So with this alternative as well, with the pile walls that we needed to include, the alternative cost was quite a bit higher because of those walls. It's the second shortest culvert of all of our alternatives. It minimizes excavation near the interstate, which we were concerned with alternative 1. So those are a couple pros related to this alternative. The main issue with this one, though, is that of all the alternatives, it's the most excavation against existing buildings. And that's always a concern when you're working next to existing buildings and infrastructure. The other was kind of the challenge, like how are we going to control water? How are we going to deal with the water in the existing pipe and the existing ditch while we're building this system? Alternative 3. This is we'll call just our blue alignment. So this one is very similar to alternative 2 in the way it starts. Our inlet is in the northwest quadrant of the interchange, goes under the exit ramp, and then it goes through the grass median area between Main Street and the frontage road. Instead, you can see on this one, instead of taking that 90-degree turn near where the existing pipe is, it continues east, and the next slide will show you where that eventually makes its outlet. The existing storm sewer along Main Avenue could be connected to this system. The existing pipe would be abandoned in place. And we would address some of the ditch issues on the south side to the existing ditch. Since we're bypassing that whole system north and around that existing ditch along the interstate, there's less flow going through there. So we do a lot of cleanup, which would help with just overall ditch function and also help with the flooding issue we were seeing at that business. Here's our Google Street View, kind of standing roughly. Obviously, Google doesn't drive in the grass, so we're not standing in the grass, but roughly where we're showing, and then you can kind of see that cross section. Obviously, here we're in an open area. We could do open trench, a little more freedom, a little more constructability. Allowed us to get rid of those walls, allowed us to get rid of or away from buildings. So this was definitely a consideration or a pro for this alternative to open up that constructability area. Here you can see where that pipe then eventually turns. So on the far left of that figure is County Road 19. That's that crossroad that goes under the interstate, give you a point of reference. And that business just to the east of there is a church. And this alternative would go to the very east side of the church property, take that 90-degree turn, head south, and then eventually daylight out to the ditch. That area of the church property is outside their normal parking area. It was a grassed area. However, it was kind of overflow parking during large mass events, Christmas, Easter, those types of things. But for the most part, it was just a grassed area that they had on their property. They were very good partners. They were willing to work with us and talk about different alternatives and different ideas with these options. At the outlet, because of where we're coming, you can kind of see it in this figure, but not really. That's soil nail well is right in within the limits of this. So we really had to have a lot of considerations on this alternative. You know, how much water is coming through here? How fast is this water now coming through here? And then what do we need to do to dissipate it, slow it down a little bit before it enters in that ditch and causes any problems that we already have on our existing infrastructure to prevent slides. Here we got our Google Street View right at the bend, looking south along the church property. You can see that grassed area. Again, here we were able to look at an alignment that allowed that open trench system, give us a little more flexibility in the constructability. Alternative 4, very similar to alternative 3. We're color our purple color. This starts off in the same area in the northwest quadrant, goes along the grass median area between Main Street and the frontage road. So it's very similar here. I'm going to skip past that. Here's where it's different than alternative 3. You can see the church and that grassed area where the last alternative turned. This alternative keeps going along the frontage road and the grassed area. The idea here was that it's looking at an alternative that outlets away from that existing slide repair and gets us away from that. What would that look like? What could that maybe be? And you know, what are some of the pros and cons related to that? This one did end up, because it's staying in that median, staying along Main Street, have quite a few bit more utility impacts than the other alternatives. And then here's where that alternative then turns, very similar turn, 90 degrees, outlets out into the ditch with the similar type of energy dissipation needed. Here's our Google Street View. You can see here on this cross-sectional view, this was an actually interesting element to this. You know, we're following our drainage profile to make sure that we can outlet to that ditch along the interstate eventually. There was a low-lying area through this private property, so we actually had a fill. Box culvert was sitting above existing ground. Interesting element with this one. So as it relates to all these alternatives, all these boxes, alternative 1, which was the very short one, it was about just over 1,000 feet of box culvert. Alternative 2 is 1,200 feet. Alternative 3 is just over 1,800 feet, and then alternative 4 here was 2,600 linear feet for comparative purposes. Based on that, the selected alignment, we ended up going with alternative 3. So that's the alternative that went between Main and the frontage road, took the 90-degree turn, went south through the church parking lot area, or church grassed area. That one rose to the top. So what we ended up with was a design that was a box culvert about 1,800 linear feet long. It's a 10 by 7 box culvert. Has that 90-degree bend in it and has an outlet system for energy dissipation. With that, I'm going to hand it over to Brandon. Okay. You got to do this to advance up there, and you use arrows to advance on here.
Uh-oh. Yeah, multitask. All right. So I'm Brandon Barnes. I'm the project manager for Barr Engineering. And for the design of this project, we partnered with SRF. SRF was really an instrumental partner here in having us deliver the project. And so if we do run short on time, there are a number of staff, both at the Barr booth and the SRF booth, that can answer questions on this project. Great icebreaker. Go and introduce yourself. What Michael didn't mention, and where he left off, is that the alignment that was selected for this project was one of the, if not the longest, box culverts that the North Dakota DOT would own and maintain. And so when you start talking about the longest, the biggest, those sorts of things, there's a number of questions that gets asked along the way to make sure that things aren't being missed necessarily in the design, and that you know what you're getting into when the project is all said and done. And so what I'm going to do here in the next couple of slides here is I'm going to highlight a few aspects of the design. We'll look at how water is flowing through the box culvert, how water is flowing through the soil, the ground around the box culvert, and then things that can be put on top of the box culvert. So another way is we'll take a highlight of the hydraulics, the geotechnical, and the structural aspects of this project. So first up is the hydraulic design, and when you think about culvert design, oftentimes you think about the energy equation, you think about the water levels upstream of the culvert, downstream of the culvert, the velocity heads, the head losses through that particular pipe. Now, the site constraints for this project certainly complicated that aspect here. We were looking for a model calculations that could accommodate open channel flow upstream of the box culvert and downstream of the box culvert. We were looking for a tool that could accommodate subcritical and supercritical flow, so really slow moving water, really fast moving water. We were also looking for a tool that could quantify the characteristics of the hydraulic jump that forms or that could form just downstream at the outlet of the box culvert. And that tool we ended up selecting was adaptive hydraulics. It's a two-dimensional model that's developed by the Army Corps of Engineers. And really the advantages, the benefits of this particular tool was we only had to run one model to be able to evaluate the interactions of water in the box culvert with the drainage ditch as well. So in particular here we were using this model to look at flow rates, velocities around that 90-degree bend, and then also at the outlet of the box culvert near the location where the DOT had just recently repaired the slide on the north side of the interstate. So as I mentioned, we used ADH, adaptive hydraulics. It's a finite element model. In other words, it's a 2D model, and we use that to simulate a wide range of flow rates to understand how the system would perform under really diverse set of flow conditions. What's shown in the image there on the right is the extents of the model. So you can see the box culvert alignment. That's the thin colored area through the frontage road, and then you see the wider area. That's the area of the open drainage ditch at the downstream of the box culvert. As we zoom in here, this is the mesh, the surface that the model is run on, and really the scale of the size of those elements varied from 5 feet to less than half a foot to be able to capture the resolution needed in order to answer some of the questions that the DOT was asking, and to make sure that we were designing the culvert and the outlet in a way that could fit within some of those very tight site constraints that Michael had described. So here's a screenshot or two of the results of the hydraulic model. Warmer colors indicate faster velocities, higher water depths. Cool colors are lower values. And there's a couple of things that jumped out here around this bend. Number one is the water depth varies based on horizontal location on the bend. And so there are larger depths on the outside of that bend, and there's smaller depths on the inside of that bend. For the 100-year event, those depths vary by up to a couple of feet. And similarly, the velocities vary as well. You get much higher velocities on the outside of that bend than you do on the inside of that bend. So there was two interesting things that came out of this. The velocities weren't necessarily uniform on the outside of that bend. Due to secondary flow patterns, you get some oscillations on the outside of that bend. The other thing that becomes interesting is the velocity. With these results, we can calculate a force that is applied on the outside of the bend, and those forces then were shared with the structural and geotechnical designers to make sure that the resisting forces on the other side of the box culvert were sufficient so that we wouldn't anticipate movement after the culvert was constructed. So that figure showed that the velocities through that culvert during the 100-year event are really moving. We're talking about velocities that certainly exceed 15, approach 20 feet per second. And so dissipating that energy, reducing those velocities at the outlet of this culvert is really important. And so the figure on the right here, this is looking upstream to downstream. The outlet of this culvert is just past the church building there on the left side of the channel, and it discharges basically just upstream of those where the slope was recently repaired. And so the design team went through a pretty comprehensive search looking at really a wide range of energy dissipators at the outlet. And those potential methods for dissipating energy were really reduced based on site constraints. What could we put at that particular location? hydraulic characteristics of the flows coming through that box culvert. We ended up settling on a precast or cast in place. Whoops, hang on, multitasking here. Where am I? Okay. We ended up settling on a cast in place outlet structure that had similar characteristics to a CSU basin outlet, if any of you are familiar. The schematic here in the middle shows the approximate geometries of the apron, the splash blocks on the downstream side of that outlet structure. The figure on the right is the representation, the schematic representation for how it was input into the two-dimensional hydraulic model. And one of the key findings or key results that we were checking as we were designing this outlet was making sure that the velocities downstream of the new outlet generally matched or were consistent with velocities for existing conditions. And so the figure on the left, it shows velocity profiles. Again, warmer colors are higher velocities, cooler colors are lower velocities. The channel on the top is existing conditions, and so velocities in that channel are on the order of 8 to 9 feet per second. And what we see on the bottom, those are velocities for proposed conditions. And so this shows that the hydraulic jump is contained within the basin or that energy dissipator. Velocities about 100 feet downstream of the outlet are on the order of half a foot higher than existing conditions. And so we designed riprap energy dissipation for those velocities. And then as you move further downstream, velocities converge and become approximately similar to what is currently exists there in the channel today or pre-project. The other thing we'll take a brief look at is how water moves on the outside of the box culvert through the soil. And so for this, the geotechnical design generally followed NDOT standard details with one exception. In this case, because there was high groundwater, there was concerns about as we replaced tighter clay soils with more granular backfill, we're creating a French drain type of effect to allow more water to drain and reach that channel, which in a couple of slides I'll talk about is something that the design team really wanted to avoid. And so we ended up installing a few really backfill dams, cutoffs along segments here of the north-south portion of the channel. The last design element I'm going to hit on is the structural design. The structural design, again, generally followed typical box culvert design methodology, but the interesting aspect here was there was a lot of back and forth with the church. In order for the project to be constructed, the DOT had to acquire permanent right-of-way on the church property. And so when permanent right-of-way is acquired, there's limitations on what the property owner can do within that area after the DOT acquires that right-of-way. And so our structural designers were answering a lot of questions from the church regarding what could be put on top of that box culvert after it's constructed. What is the loading that a swing set applies? What's the loading that a playground applies? Define playground. Is it a couple of swings, or is it a giant structure that you're gonna load on top of the culvert? So there was some very unique questions that were coming from the church that the structural team iterated through in order to provide the church with reassurances after the DOT purchased the right-of-way. So as the design was progressing, the team encountered several surprises that left certainly the design team, the DOT, the city, smiling, shaking our heads, adjusting as we worked through this process. And so the first one here was brought up after we were on site. This was following a utility locate meeting, talking about impacts, relocations that were needed, and the meeting was wrapped up, and one of the locators said, "Okay, this is great. Now, what are you guys going to do about the dump site that was in this parking lot?" Excuse me? So we followed up on the comment from that locator, and sure enough, This was the location of the municipal dump that was in operation from the early 1900s to about the mid-1900s. The dump hadn't been properly closed, and as such, the documentation was limited. And so the team worked through a phase 1 and phase 2 investigations that revealed that it was primarily used to burn municipal waste. So a lot of the debris that was there was inert, but we would have to encounter it as it was along the alignment of our proposed culvert. The next surprise that came up as we were talking with the church, the property owner, about the dump that exists within their parking lot. They said, "This is all great, they were wonderful to work with, we support your alignment, you can go ahead and you can build along that alignment, but gosh, we really like our geothermal system that's in our parking lot. How is this gonna impact our geothermal system?" Excuse me. So talking with the congregation, they had installed a geothermal system in the mid-2000s, and at the time there was no plans, there was no design for that geothermal system, there was no photographs available at the time. The superintendent that installed the geothermal system had since passed away and didn't have any construction notes. So the only thing that the design team had to go on was that sketch in the upper right corner. And so we subcontracted a potholing company that was out there with a vac truck to try to find the eastern extents of the geothermal system. We ended up having to do this in the summer so that if we broke that system, we could repair it before it was needed in order to heat the building during the winter. And we had to find those extents so we could collect geotechnical borings east of that geothermal system to inform the design of the box culvert. Wouldn't you believe it that after it was all said and done and the DOT was working through right-of-way negotiations, this photo surfaced, and the eastern extents of that geothermal system was exactly where that photo shows that it should be. So the other surprise that came up, or another surprise that came up, and this was maybe less of a surprise in hindsight given the historic dump site that was present on the property, but the phase 2 investigation indicated that there was contaminated groundwater and contaminated soils present along the alignment. There were elevated concentrations for metals, and while this didn't necessarily substantially affect the design of the box culvert, what it did mean is that there were extra provisions that were put in place, directions to the contractor in terms of how they had to manage that water. Essentially, any water that came into those areas, into their open trench, had to be collected and then disposed of off-site. It couldn't continue to flow into the ditch. Hence the reason for those cutoff walls and us not wanting to increase flow to the existing drainage ditch. And then the final surprise that I'll hit on here is the last one that came right before we were ready to sign the plans. We were working through the design at a point in time where box culvert procurement in some cases took an extremely long time. And there was direction from DOT management that box culvert project should look at an alternative that did not include a box culvert. And so here we are designing one of the longest alignments, box culvert alignments for the DOT, and we sort of took a step back and scratched our head and said, well, gosh, what would this look like without a box culvert? And so we threw a bunch of things at the wall, including looking at purchasing some of these businesses, relocating some of these businesses so it could be an open channel through there. And in the end, it wasn't economical. It wasn't. The social impacts were fairly significant. The other thing that we did during that process is there were ongoing conversations with precasters and box culverts section suppliers, and those conversations indicated that we anticipated a construction duration of 2 seasons, and so we adjusted the contract documents to allow for a winter suspension, understanding that the procurement of those sections could take quite a bit of time. So with all of the surprises, hopefully, in the rearview mirror, so to speak, the project was bid in the winter of 2024. And the first surprise from a construction perspective was that Those box culvert sections that everyone was telling us was going to take up to 2 years to procure were all on site, ready to be installed by the beginning of June. And so this was a pretty big curveball. Number one, because there were a lot of box culvert sections now that the contractor had to figure out what to do with. There were sections on the right-of-way adjacent to the ditch, and there's in there along the alignment, the contractor had an off-site storage area, and they were bringing sections on as they had opened sections of the trench. It really became kind of a logistical challenge for the contractor. For the DOT, this was a good thing, because now our construction schedule went from a two-year schedule to really we're at or really close to substantial completion last year. There's a few miscellaneous items that need to get wrapped up yet in 2025. So this was a positive surprise. Here, just looking from a few photographs, construction photographs, to give you a sense of scale and how the project went, starting at the downstream end of the box culvert and working our way to the upstream end. This is construction of the outlet, setting the rebar, the sheet pile cutoff wall on the left, pouring the precast or the cast in place apron, and then when it was constructed, they were letting water flow through the ditch again on the right side of the screen there. Water management proved to be really tricky throughout the process. The contractor used a number of means and methods in order to keep water out of the work extents. Sheet pile cutoffs in the ditch, plywood, sandbags, you name it, they tried it. Here we're standing in the church property and looking south towards the ditch. I like this photograph because you can see the granular backfill to the top of the box culvert that really matches the DOT standard box culvert section. When they got up towards the frontage road, the means and methods changed more from an open cut to now more implementation of trench boxes, again being real cognizant of the limited right-of-way that they were working within, trying to avoid those impacts to those storage units, but also the other parcels along the right-of-way. I mentioned the dump site and everything that you would think would be encountered when you excavate through a dump site was encountered. Crock pots, whiskey bottles, there was reports of portions of cars. One of the stories that I got on a phone call was the contractor got a kick out of pulling whiskey glass bottles out of the excavation and then dating the bottles based on when the distillery was in operation. And reports are that some of these bottles dated back to the late 1800s, which again makes sense given when the time frame that we anticipated that dump was in operation. Of course, there were big boulders that were encountered. These are photographs where the contractor, I like these, they were good enough to park those boulders right next to an excavator for a sense of scale for what they were encountering through the ditch. I had mentioned contaminated groundwater. This was maybe another one of those surprises that came up during construction. 2023 was a really dry year. 2024 was not. And when all of those box sections were on site, the contractor was opening up the excavation, and then it rained. And when it rained, that water had to be collected. It was put in tanker trucks and then disposed of off-site. Valley City Wastewater Treatment Plant stopped accepting the water that was collected as part of this project, and then it continued to rain some more. And so the contractor eventually was disposing of the water that they were collecting in their excavation in Fargo. So they were hauling the water to Fargo in order to dispose of it. Here's one of those bends. This is right near the inlet of the pipe. And then here, this in the photograph on the right, you can see the inlet for the new box culvert in the foreground. The inlet to the existing old pipe is in the background. And then the photograph on the right shows that the old pipe being removed and just the inlet remaining. This was, when this happened, I got a call in the field, and they said when when they pulled the plug and made the switch, folks went to the downstream end of the box culvert, and I got a call saying it was really anticlimactic. Water just came trickling out. I said, good. That's the way it's supposed to work. So for those low flows. So the new culvert is in operation. And like I said, there's just a few miscellaneous things to wrap up. And so I think here I've just got a couple of slides left. And this last one here, I will give a concluding remarks from the consultant's perspective. And I think there's a lot of lessons to be learned in this project in particular. But if I was to just highlight one or two of them, I'd say one is the importance of talking to material suppliers, understanding when product can become available, what your contingency plans are if it's not available, and then making sure that the construction documents match that. So the other one is that I'm calling it change management here, but I also think it's the understanding of institutional knowledge, talking with, in this case, the church congregation, the utility locator that happened to be aware of the dump at this property. The city had a lot of staff turnover at this point in time, and so some of that institutional knowledge wasn't there. And so connecting with the folks that had the history for this site was really important to informing how our design evolved and eventually ended with a successful construction project. And so I don't know if Michael's got one more concluding statement from the DOT perspective.
Yeah. Thanks, Brandon. Well, I hope you guys thought that was entertaining. But what was interesting about it from the DOT's perspective, we reached a point where we were ready to select an alternative. We had went through all the environmental processes, and we had an environmental document ready to go, presented it to our management team, and we kept getting a lot of questions back about like, well, did you look at this? Did you try this? What about this option? And we responded to each one of those in kind. And, thought we had taken care of things. And it's like, well, what if we did this? And what if we did this? And we couldn't really understand, why do they keep asking? And finally got to the bolts of it, is that the thought was, and the comment was, we're going to spend $10 million here, and nobody's going to know we did anything because it's all buried underground. So once we got over that hurdle and we really realized what we're trying to accomplish here, we were able to move forward and get this project accomplished. And I think it was very successful, and appreciate your time and hope you enjoyed the story. Thanks.